Section 0.1, Economics of Energy Production and Distribution. The book is divided in 4 main sections. The first is devoted to the economics of energy production and distribution and has separate chapters for all major sources of energy. Chapter 1 is devoted to oil and gas exploration and production, the so-called upstream section of the hydrocarbon industry. The chapter explains the different phases of an exploration production project in order to highlight the cost structure and the nature of the risks related to each phase. It also discusses rent sharing according to the different taxation systems and points out the profitability problems of this capital-intensive industry. As it is not possible to know in advance whether oil or gas, or neither, will be found, exploration is necessarily common. Furthermore, gas is frequently found in association with oil in fields containing predominantly oil, and liquids are frequently present in gas in predominantly gas fields. Hence, the production of oil and gas is commonly joined. However, once brought to the surface, the paths of oil and gas diverge. The transportation of oil is relatively low cost. Oil easily travels over long distances. Therefore, separate discussion of oil transportation was not considered necessary. In contrast, gas transportation is expensive and has important implications on the industry. Gas tends to be utilized close to where it is produced to reduce the cost of transportation. Hence, the penetration of gas, or share of gas in total energy provision, varies very considerably between countries and regions, depending on whether gas is available, or historically was available, locally. This does not mean that gas is not transported over long distances. This is in fact an increasingly frequent occurrence. However, the high cost of transportation justifies significant differences in the price of gas in different parts of the world, which obviously also affects its relative competitiveness and which final uses it may be demanded for. Gas can be transported either in gaseous form by pipeline or in liquefied form by dedicated ships, LNG carriers. Chapter 2 provides a focus on the economics and commercial aspects of these large, often multi-billion-dollar infrastructure projects, characterized by high upfront investment costs and requiring complex risk-sharing mechanisms between all parties involved. Gas, once brought to the destination where it is demanded, normally does not require further treatment. The separation of higher molecules is made at the production site and what is transported is almost exclusively methane, CH4. In contrast, oil must be refined in order to be transformed into usable products, depending on the technical characteristics required for each of its multiple uses, such as fuel, gasoline or diesel, in internal combustion engines, in aviation or shipping, in heating or the production of lubricants and so on. The process of refining is sensitive to the quality of the oil fed into the refinery, to the configuration of the refinery, that is, the number and quality of units, processes, available in it, and to the desired composition of the product slate. Refining is discussed in Chapter 3, where the key processes are explained together with their costs and sitting issues. Historically, most oil has been refined in proximity of final markets, but this is no longer necessarily true, as producing countries are striving to integrate downstream into refining and petrochemicals to capture more of the value added than is allowed by the exportation of oil in its crude form only. Less demand in Europe and more demand in Asia have deeply changed the structure of the industry with closures of facilities in Europe and development of large, sophisticated plants in the Middle East and Asia. Chapter 4 is devoted to hydrogen, which, in a sense, constitutes the bridge between the discussion of hydrocarbons and that of electricity that features in the following group of chapters. Hydrogen is not a primary source of energy because it is not found in isolation in nature and needs to be separated using energy. It is therefore an energy carrier rather than a source. At present, it is produced predominantly from hydrocarbons without carbon capture and sequestration, and is therefore a significant source of CO2 emissions into the atmosphere. It is used predominantly for its chemical properties in refining and the chemical industry, rather than as carrier of energy. But the future is expected to be completely different, because hydrogen can be stored and offers a flexible source of both heat and electricity with no emissions of greenhouse gases. If produced from hydrocarbons with carbon capture and sequestration, it has the potential of decarbonizing hydrocarbons, allowing the continued use of gas grids where they exist. It can also be produced from water through electrolysis, stored and turned to electricity again at some different time. It is therefore a form of electricity storage which is potentially crucial to facilitate the integration of non-dispatchable renewables into the grid. We come therefore to the discussion of the electricity industry. Chapter 5 is devoted to the economics of power generation. This is a complex topic, due to the multiplicity of technologies available for power generation. The chapter introduces the major economic differences between the multiple power generation sources, highlighting the comparative advantages and disadvantages of each. Chapter 6 is devoted to power generation from fossil fuels, coal, oil and gas, which constitute the bulk of global electricity generation, 63% of total, of which 36% from coal, 23% from gas and 3% from oil. It covers the various technologies of power production and their key economics characteristics including CAPEX, OPEX, dispatchability, flexibility, location and expected service life. Chapter 7 is devoted to nuclear energy, 10% of global power generation. It starts with the fundamentals of nuclear economics, with first the cost of nuclear operations, and also the revenue side, in both regulated and deregulated markets. Then it goes in depth into analyzing the economics of two specific cases: long-term operations of existing nuclear plants and nuclear new build, covering potential for cost reductions in the case of small modular reactors. The chapter concludes with a review of new research to understand the value of nuclear in future decarbonized electricity systems. Chapter 8 is devoted to hydropower, 16% of global power generation, which is one of the oldest power generation technologies and the source of the largest power stations in the world. Despite a phenomenal rise of new renewable generation technologies, hydropower remains responsible for most of the renewable electricity generation around the globe. This chapter explores the economics of power generation from hydro and its advantages as well as disadvantages. It describes the characteristics of the three hydropower generation types: run-of-river, hydro storage and pumped storage, and provides an outlook on the future role of hydropower in modern energy systems. The following two chapters deal with solar and wind, together accounting for 10% of global electricity. Solar energy, Chapter 9, covers an increasing share of global energy demand. As a renewable source of energy, it will play a major role in decarbonizing electricity supply. The chapter provides an overview on the solar sector from an economic perspective. It describes the technical characteristics of photovoltaic and concentrated solar power and explains how these affect the economic competitiveness of solar energy. Wind power too plays a major role in decarbonizing electricity supply, Chapter 10. The chapter provides an overview on the economics of wind energy and highlights global trends in the wind sector. It describes the technical characteristics of onshore and offshore wind energy and explains how these affect the economic competitiveness of the technology. In both chapters, the authors describe how solar and wind power, as intermittent sources of energy, can be integrated into power systems. They also discuss how renewable energy support schemes contribute in fostering the deployment of solar and wind power. The remaining two chapters are devoted to geothermal, Chapter 11, and tides and waves, Chapter 12, two renewable sources of electricity which presently play a very limited role, but are believed to offer considerable potential, geothermal in particular. Geothermal energy is emerging as one of the most reliable sources of renewable energy and gaining relevance over conventional and non-renewable sources of energy because of its constant availability and sustainable nature. Besides being a clean and renewable energy source with a low levelized cost of electricity, geothermal reservoirs have huge potential for power generation and thus may become the pillar of local grid systems, meeting baseload. The above group of chapters deals with the economics of generating electricity, but that cannot be considered in isolation from the economics of electricity transmission and distribution, especially in view of the characteristics of the electricity grid, which requires instantaneous matching of demand and supply at all times. The following chapters deal with these issues from different angles. Chapter 13 looks at the economics of energy networks, both electricity and gas, including from a regulatory point of view, that is, how the power and gas industries may be organized competitively and what challenges this entails. The chapter describes the physical and economic properties of energy networks, focusing on their monopolistic nature and the implications for electricity and gas systems. It goes on to review how energy networks are treated in competitive energy markets, how access to networks functions and what arrangements are established to ensure efficient economic outcomes and equal treatment of all market participants. Finally, it explains how access to energy networks is charged and how network users exchange energy within a network. Chapter 14 deals with the challenges and opportunities of energy storage, with a specific focus on the economics of batteries for storing electricity. Storage technologies include a variety of solutions that have been used for different grid services, including frequency control, load following and uninterrupted power supply. Next, Chapter 15 provides an introduction to the main characteristics of sector coupling, which is often referred to as P2X, where X may stand for various applications, such as gas, G, heat, H, vehicles, V, or others. The common feature of these technologies is to provide additional flexibility to the power grid by the integration with other energy networks or sectors, through the conversion of electricity into other energy carriers. In the light of the discussion in previous chapters, Chapter 16 deals with the integration of non-dispatchable renewables, i.e. solar and wind, whose availability cannot be controlled by the producer, into the electricity grid. At low levels of deployment, these technologies typically do not raise significant issues, but to reach high shares of generation within each power system, several measures are needed to integrate them in the overall electricity mix. The chapter reviews various potential approaches and discusses the challenge of reaching high levels of penetration of non-dispatchable renewables, while at the same time maintaining the stability of the grid and avoiding recurrent blackouts. The last chapter in Part 1, Chapter 17, is devoted to the financing of energy investment, which is closely related to the economics of each energy source. Energy projects can vary enormously in scale, risk, and potential reward. Accordingly, different financial models need to be applied to optimally finance different topologies of projects. Also, different categories of investors, ranging from low risk to very high risk, must be tapped to succeed in financing projects. In the context of the substantial investments required to sustain the development of world's economies, this chapter reviews the key steps in the financing of an energy project, from the project viability analysis to the choice of financing instruments and structures. The authors highlight how the source of energy and the other characteristics of a specific project impact and shape its financing, using case studies from renewable and conventional energy alike, and conclude by drawing attention to the innovations taking place across all energy segments.